Hello everybody, let's move on to the motion along a straight line of kinematics or rectilinear motion you say. Earlier we did with measurement, but I didn't take a lot of problems so, but uh, the problems are more of theoretical part and stuff like that. So we'll do the problems in our maybe in the class. And, let's start with kinematics as soon as possible. First of all, I'm using currently NTG book. That is which edition? Maybe two साल पुराना वाला edition होगा. I don't know. I don't know. I have to see that. But then it, it's really simple. Let's start. Frame of reference. What actually frame of reference mean? Or reference frame or initial frame of reference we say. A frame of reference is a point from where we observe things. Alright. From where we observe things. It could be either velocity, acceleration, anything. But frame of reference is what we represent. I mean, what we there. जहाँ पर हम खड़े होते हैं and the way I look, the way I observe things, that is a reference frame. And then becomes motions. What motion is like anything which moves has a motion. Or if everything in the world or everything in the universe has motion, we can say like that. Because if I move, then for me, if I choose myself as a reference frame, then I'll see that thing moving. All right. So motion is like continuous. It's almost everywhere. We are like traveling almost like miles per hour, or maybe kilomiles per hour, like that. Then comes vector quantities. Vector is mathematical, so we won't be able to take vector quantities. Whereas we'll discuss about vector quantities later. Distance and displacement. So not actually distance and displacement. For that, finding displacement, position, average velocity. What is position? Position is described by, like in our world, it is described in using three axes: x-axis, y-axis, z-axis, and one more which is more kind of like theoretical. That is time. The x, y, z, and there is time, space, and time. X, Y, Z represents space, and z represents x, Y, Z represents space, and another one which represents time. All right. So this thing tells about position of the body, where the body is, and at what time the body is, when the body is, or where the body is, and when the body is. Then comes distance. Distance is the whole lot of everything you travel, no matter what you go in circle. That one circle would be if you make one circle, then it will be 2 pi r. That is perimeter, or that is the circumference of the circle. Then what is displacement? Displacement is a vector quantity. Again, displacement does. I mean, displacement. If you like again go around a circle, then your displacement for once your displacement would be zero. That's the shortcut thing. The displacement is kind of more shortcut kind of, and displacement is the long cut you take every time. All right. Then comes speed. Speed we know speed is a scalar quantity again. That is the total distance traveled by total time taken. Then comes the average velocity. Average velocity is total displacement by total time taken. Total displacement is due to velocity time divided by the time. So you get average velocity. All right. Yeah. Here the formula is. Then comes this is the position and displacement graph, or maybe a representation. Represents how a woman moved from like around 0.5 kilometers, came back 0.5 kilometers. So how much she traveled? That is distance. How much she traveled? That is 1 kilometer. And what's her displacement? Then if we say like that, I would say zero. I mean, she went, she came back. So that's almost a zero. Almost like pura ही zero. And we have studied this thing in our 8 and 9 standard, no matter what board it is. So if you really don't know what I'm saying or don't understand what I'm saying, you can message me or text me. I'll I'll give my email ID there. Or and that's all. Let's roll. Position versus time graph. So position versus time graph gives me what? The area under the curve, the area here, all these areas, this triangle area, enclosing this thing, everything, even this one, gives me velocity, speed. Because I'm talking about position, right? So if you take a derivative of position, you get a velocity. If you take a derivative of velocity, you get an acceleration. Then instantaneous velocity and speed. So that's what we most of the cops use it. It represents, it shows instantaneous velocity, how fast they are moving. So you might get question on this thing, uh, like someone is chasing you, or maybe you are like behind chasing someone. So what's your average velocity or stuff like that, or what time it take you to catch him, or maybe uh, like go beyond it, go forward, or go around same speed and all. There are many cases. I'm just skipping a lot. I think I know, but this is what I prefer. I mean, just to say you like what actually things are. Then if I go in deep, then it will be a lot of like stuff, lot of maths and stuff like that. And I'm not a maths person. I never studied maths. So actually, I studied maths till high class, I believe. So I never love maths, but I do play with numbers. So these are the slopes representing the velocity. So if I tell you uh, if I tell you suppose this is y-axis and this is x-axis. I'm representing x as I. It doesn't matter. And we don't have a z-axis up here. It's two-dimensional, two-dimensional, 2D thing. So what I'm about to say, here it is. Have you ever seen something like this? Have you ever seen something like this? I mean, I want to show you guys a new screen. Then you have a whiteboard, making something like this. This is the position time graph. Have you ever seen like this? It represents two particles at a same time. If this is time axis, I'm sorry, I'm very bad at this. And if you represent this as a position, oh man, I'm so bad at this. This position, alright. Position, yeah, somehow it looks like ration. This is position, this is time. This represents the particle is at two places, same time. That is entanglement. We'll talk about that happens later. And let's get back to our average speed is easy again, distance by time, the total time taken, total distance traveled. And let's go back to this. And then we have a velocity, instant velocity, we did it. Some of the sums. MT has a illustration 1, 2, 3, like solving the differential equation, taking differential equation and finding out the answers and such. Area under the curve. Then we have a vector which is combined with this one. Then we move on to relative motion, or actually relative motion is relative motion and river crossing problem and stuff like that. We'll do in I think maybe next time. Maybe next time. Or should I complete projectile motion? Well, next time we'll do vectors maybe because it's important. I mean, yeah, you really need to know what a vector is to solve most of the things.